Policy Search on Aggregated State Space for Active Sampling. In this paper, we present an anytime adaptive sampling technique to efficiently measure a scalar field by performing non-uniform measurements in the region of interest. Increase in the sea surface temperatures has resulted in widespread coral bleaching at an ever-increasing rate. This motivates our application of monitoring the health of coral reefs by sampling visual data from the surface using an autonomous surface vehicle. The block diagram gives an overview of our approach. We train our policy-based sampling algorithm with the score map computed as a multispectral function of the satellite image of a reef. During the learning phase, we introduce 5 kinds of state space aggregations. All the representations are robot-centric. Here we illustrate the feature representations tried with our approach. Uniform grid feature design uses all the grid cell values to make a decision on the action to be taken. 4-feature aggregation has 4 features comprising of all the grid cell values on left, top, right and bottom of the robot's current position. 8-feature aggregation of state space is illustrated in this figure. 24-feature aggregation of state space is illustrated here. In the multi-resolution aggregation, the feature cells grow in size along with the distance from the robot location as depicted. We compared all 5 state aggregations on an example grid world and found the multi-resolution non-uniform state space representation to perform better than others. We present 2 test scenarios. One of them is a densely populated reef. The second test scenario consists of reef with scattered coral heads. The path generated by our technique clearly minimizes the sampling over sand and maximizes the visual sampling of corals. Since we are sampling from the surface, higher information gain is provided in shallow regions where visibility is better. We believe that improved monitoring of coral reefs would improve the currently poor understanding of the spatial and temporal dynamics of coral bleaching. One of the novel aspects of this work is the use of a non-uniform state representation for policy search, which has rarely been explored in the literature. We compare our sampling algorithm with the traditional exhaustive sampling technique using booster-Freundlich path. The total score collected by both the approaches is comparable. However, the total discounted reward achieved by our method is significantly higher when running on a scattered coral head scenario. This indicates that the proposed approach tends to gather most score early on in the trajectory, resulting in better anytime performance. We use both a custom-made and a commercial autonomous surface vehicle to survey the coral reefs from the surface to collect visual data. The preliminary results suggest that our sampling technique can have a major impact on the efficiency of state exploration, as demonstrated by exhaustive experiments using real but stored data from real field deployments. We expect to further validate this expectation in data from field deployments to be reported in the final manuscript. For further results and discussions, please have a look at our paper. Thank you.